Hi everyone, in this video we are going to discuss some very basic concepts of circular motion. A circular motion is a motion in which a particle moves around the circumference of a circle. Like in this particular diagram, as the particle moves from point P1 to P2, it follows a circular arc and hence it's an example of circular motion. Few of the examples of circular motion could be electrons orbiting around a positively charged nucleus or planets orbiting around Sun. First of all, we need to understand what is meant by angular displacement. As the particle moves from one position to the other position, the radius also moves along with it. So, as the radius turns through, it sweeps an angle and the angle turned through by the radius is called angular displacement. Angular displacement is going to be measured in radians. We relate the distance moved by the particle s, the distance of the particle from the axis of rotation r, and the angular displacement theta by the formula s is equal to r theta. To define radian, we use the same formula, which is s is equal to r theta. If the distance moved along the circumference, that is s, becomes equal to r, then if s and r are equal, they cancel out and the angular displacement is equal to 1 radian. So, the definition of the radian is that it is an angle turned through when arc length becomes equal to radius. You can also use this conversion ratio, which is 180 degrees is equal to pi radians, to convert any angle in degrees to radians. The next term we need to understand over here is angular velocity. Angular velocity is the rate of change of angular displacement, that is angular displacement per unit time. We represent angular velocity by omega. So, if we take the previous formula, which is s is equal to r theta, and divide both sides of the equation by time t, then the distance along the circumference divided by t should be equal to speed of the particle, whereas theta upon t must be equal to angular velocity. So, we get ourselves another formula, which is v is equal to r omega, where v is the speed of the particle, r is still the distance of the particle from the axis of rotation, and omega is the angular velocity. Few more terms that we need to understand include the uniform circular motion. So, if it is a circular motion with a constant speed of the particle or a constant rate of angular rotation, that is angular velocity must be constant, then this kind of a motion is called uniform circular motion. The time period t is the time taken for one complete rotation, whereas as far as frequency is concerned, it is the number of rotations per unit time. As per definition, frequency and time period must be reciprocals of each other. So, we get ourselves a formula which is f is equal to 1 over t. Frequency is always going to be measured in hertz. So, when we talk of a uniform circular motion, we already know that angular velocity is the change in angle upon time. So, if we consider one complete rotation, the change in angle must be equal to 2 pi, and the time taken for one complete rotation must be time period. So, we get ourselves a formula for angular velocity as 2 pi over time period. And since 1 upon t is equal to frequency, another way of writing down the angular velocity could be omega equals 2 pi f.